So welcome to blockchain. I guess as a before we get too deep, this is going to be a high level look. There's actually I don't think I have any code in this at all. So if you know anyone that was like, oh, it's going to be just a technical thing, just ping them quick, let them have them jump in. Don't be scared. It's fine. Um, I think my overall view on this is I'm going to kind of stop and ask like, hey, do you guys have questions on what I just talked about? Because we're going to cover a lot of concepts, and then they're kind of going to link together later on in the presentation. Because you kind of have to just know pieces before you can got to get a whole picture. Um, so that's where we're gonna start with this. Um, let's see here. Oh yeah, and I guess my main premise in this one, if you want, we can always talk about the more in-depth things in future lunch and learns. I've got a whole list of stuff I'm more than willing to talk about at the end of the presentation, but the idea now is to kind of give you an idea of in the media you're going to hear a lot of buzzwords like Dogecoin, cryptographically signed blockchain, blah blah blah, all these things, and it's like, what does that actually mean? Like, everything's private. It's like, well, sorta. Um, so the idea here is to give you more of a technological look at like what blockchain is versus this is not an investment one. Like, people are talking about all the money you can make. We're not going to talk about that. We're going to talk about the underlying technology and like what it can be used for, what it is being used for, things like that. Um, and actually, as a little teaser, we at Yahara are actually doing something in blockchain. There's a project we have that's in the early stages. We're going to talk about that a little bit later down the road. So, with that premise in mind, let's just dive in. So this is a quick history, and like by no means an in-depth history. Kind of the main idea here is to get you to. Blockchain is not a new idea. It's an iterative idea built on other ideas. Distributed computing has been around since what, the 90s or maybe earlier. We use it all the time. Our anytime you go, oh, our AWS instance is down, good thing our backup kicked in. Like, that's the idea of distributed computing. Then this guy or group of people under the pseudonym Satoshi Nakamoto created the Bitcoin network, and that's kind of like the first established blockchain. And then as things developed, cryptocurrency started being used like for cash transactions, and then as like a digital payment system, and then you start getting applications being built on blockchain that don't just deal with money. You have smart contracts, which we'll delve into a little bit later on, start to develop, which helps with like automation and things like that. And then you're getting like permissions, market evolution, all these things. That's why it's kind of more in the mass media now, is things are actually being done with it, and it's not just this technology for technology nerds. Um, so, what is blockchain? Well, there's a lot of buzzwords, as I mentioned before, but no one definition is entirely true because you can't just jam it into something like this. Like a decentralized distributed network that anonymously and cryptographically records data to an immutable public ledger. Cool. First, what does that mean? We'll talk about that. Second of all, that's not always true. So, it doesn't always have to be decentralized. It's usually a distributed network, but doesn't have to be. You could have like one server sitting there running the entire chain if you wanted to. Um, it's rarely anonymous. I mean, cryptography is kind of part of blockchain. I suppose you could decide to not use it, but then it's not really a blockchain. Um, you can have private and restricted networks, so that's not like they're not always public, not publical. Um, and then immutable, sort of. It's through network agreement. Immutable, you can't change it, is the idea there. And we can talk about this a little more when we get into consensus algorithms and stuff like that. But really, the idea is to show you that anything you're reading in a headline is probably not quite true. They're doing their best, but there's a lot of um, subtleties to it. Um, so, how they work. And after this, I'll pause for some questions if anyone has any. So first of all, depending on the network, they can work differently. You may have heard of like Bitcoin's one of the big ones, Ethereum's one of the big ones. We're using Cosmos here at Yahara. Cardano, Solana. There's a Dogecoin. There's all these things out there. But in general, if you imagine like a bus stop, you have a bunch of people showing up to the bus stop and they want to get on the bus to go somewhere. So as they filter in, the bus fills up, and then when the bus is full, it takes off. Or at a set interval, if it's not full, it takes off. That's kind of how these things work. You have a bunch of transactions coming in, they get put into a queue, um, they get filtered into a block, and after a certain amount of time, the block is then, finished and then, moves on and gets added to the chain. So at a high level, that's essentially what you're doing is you're taking all these transactions, putting them into a thing, and then adding it to the ledger and the rest of the chain. But you also, it's not quite like that because now imagine your bus driver is a little corrupt. He takes some bribes. So, some of your transactions maybe have a little bit more money behind them, a little bit more weight. Um, they kind of get to the front of the queue and then they go first. So that's when, if you've ever heard of the term gas fees and Ethereum, like transaction speeds, that's kind of where that comes in. Is somebody wants something to happen faster, so they pay a little bit more money to have it happen faster. And then I guess a more technical explanation of all that. Sorry if your eyes glaze over. So a user is going to submit a transaction to the chain, and that will have a transaction fee associated with it, which is usually it's going to be the expense of like processing each byte with the byte size of that transaction, and it can be anything. It could be monetary. It could just be running a chunk of code, anything like that. And then typically you also have a minimum free fee, and that's mostly to prevent DDoS attacks. And actually, fun story. Solana network recently has been running into this issue. If you've seen these headlines about having to reset their network, their fees are so low that um, essentially a big drop. If anyone knows what NFTs are, a big NFT drop was happening, and well, not really hackers, some people had a bunch of bots on the network that flooded the network with over 6 million transactions a second, trying to basically mint these things. And because it was so cheap for them to do that, they crashed the network and it had to be reset. So that's Solana can handle like 60,000 transactions per second, not 6 million. And so that's why they add this minimum fee. If you had some small amount, you would basically prevent people from, hitting your network with millions of transactions. Um, so once you've submitted this to the network, it hits a memory pool, which that's where kind of things get ordered and filtered. Um, and that's where they wait essentially to be committed to a block. Then the block is full of your and other transactions. Once it's full, or a set amount of time has passed, kind of depending on the network here too, it's validated by a full node on the network. We'll talk about nodes in a little bit. The node will then cryptographically hash that block. We'll talk about that later. And add it to the ledger. We will talk about that later. Um, and then once that new block has kind of been approved and validated and linked to the chain, that update is then transmitted to the rest of your network. So that's kind of the basic flow of how transactions get pushed through. And then I guess just a caveat to depending on the network, a block can have different sizes and different speeds. As an example, Bitcoin has a set size of a megabyte per block, and it is set to have one block every approximately 10 minutes. So that's why you hear about, oh, it's too slow to really handle like real world transactions, which is true and false. So, does anyone have any major questions on kind of what I've covered so far? Like I said, we'll kind of cover blocks and ledger and all that as in the future.
My only my only addition right now, and
Yeah.
it's not really a question, is the idea in your first page it talked about what the ledger was and what a block was, and
Hmm.
there's a concept of a unit of work. And I think that's an important thing to talk about right now in the sense that that cryptography piece is the unit of work, and it's what allows, the chain to be that to have that integrity. Um,
Yeah.
so that it's why those pieces are in place is what allows this technology to really make sense, so
Correct.
that somebody just can't impersonate a spot in this chain and say, "Hey,
Hmm.
I'm not real." It's that unit of work that allows that to occur.
Yeah, and we can,
So
and that's actually a really good point to bring up. And we can dive a little more. I've actually got it. We're gonna talk about like Merkle trees and stuff, which might dive a little more into that too. Um, that is a good point.
I have
Um,
a
yeah,
quick question around your minimum fee. So,
yeah.
how does that actually stop a denial of service attack?
So
What does it
it
do?
makes it prohibitively expensive essentially because each time you submit a transaction to the network, you're going to have to pay a fee to do so, even if your transaction is like 1 byte or something super tiny. Um, if you add on that minimum fee, it's going to start costing you millions of dollars to start like hammering a network. Instead of if you didn't have that, if your byte if the sorry if your the thing you're submitting is so tiny, it still has to be processed and all these things, and there's only so many connections to the network. Um, so you could, if you don't have that additional fee, the math that works out depending on each network, it would be so small that you can do that sort of thing. But by just even adding like a cent or two to each transaction cost, um, it would eventually make it prohibitive. Like, so 6 million times 60 times a penny or whatever in a minute, you're going to charge what is that, $100,000 or something like that. Um, $600,000. I can't do math that quick. Um, so does it answer your question or
Yeah, it does.
cool? Um, Anything else? Otherwise, I'm going to bump on to ledgers.
How are those fees collected?
So those fees are collected actually through coin on the network itself. So when you're submitting a transaction to the network, it'll say like, uh, so in the case of like the Ethereum chain, I want to send my Ethereum from one wallet to another. That is a transaction, and it will have a certain. Basically it calculates the size of that of the code to execute that transaction, and then gives you. So that's like your byte cost or like your transaction size. Your byte cost is going to be how like kind of based on the load on the network. There's an algorithm that goes on how much each byte at this moment costs. It'll multiply that, and then you would actually pay that with Ethereum that you have in your wallet, or and we'll talk about wallets a little more too later. But you'll have currency of the network in order to pay the network. Make sense? At least
Yep.
at a high
Yep.
at a high
That's
level.
great. Yes. Yep.
Cool.
That's great. Thanks, Josh.
Sure. Um, any other shout outs? Cool. All right, Ledger. So ledgers are not new. Um, you may have heard about them from in marketing or what am I trying to think of, accounting. Actually, the earliest known ledger is clay cuneiform from ancient Mesopotamia. At least that's the earliest I was able to find. It was actually tracking food disbursement in like 1800 BC. That's what this picture is actually a picture of. So kind of cool, but we're still using kind of that basic idea even today. Um, and ledgers actually don't require a blockchain. You could have a ledger database that does a lot of these same things without the blockchain submitting to it. Um, so here's AWS's quantum ledger database. The main idea, I guess, here is to really talk about like a standard database. You're going to have a sequence of transactions that add, delete, change entries, and you can get records of those changes sort of based on logging. And we've all used kind of standard databases, and it's easy to just change information as needed. So you have like a current state. You can have like captures of past history, but it's more about what's going on in it right now. A ledger database. Now this is going to be a little technical, so just bear with. A ledger database, they're going to add a layer of like digital signing to each transaction so that anyone can audit the list and see that it's been constructed correctly. I don't really want to delve too in the weeds on this kind of idea because we could have a whole lunch and learn on this. But the big idea for our purposes is that these digital signatures chain together so you have a whole history getting formed, one after another, and that's where you're seeing like your add deletes everything, so that it's not like you're just removing, like a number isn't just changing in a field in your database. It's, you're getting a full history record of that happening. And taken together, all of them, all the signatures and all the rows over time certify that a sequence of data has happened, and an auditor can actually go back and look and to make sure everything is correct and that no one has gone back and like changed history in a sense. They can't just go back and say, oh, 2 years ago actually I had $6 million added to my account, or this car actually belongs to somebody else, or something along those lines. You can see all of those changes happen. And this is kind of key to how blockchains work, I guess. Yeah. Yeah. So nodes. Okay. So nodes make up a network, right? You'll hear about like a mining node, and people are they're running their Bitcoin miner in order to make mining or and to make Bitcoin. Um, that's one type of node. Really, you've got full nodes are the important one to talk about in this context. But a node is essentially one computer on the network that's making, or that in the network that follows the rules and shares information. There's a bunch of different types of them, and depending on your network, you may or may not have them. Like Bitcoin's not going to have an authority node. Ethereum's not going to have a lightning node, things like that. But in simple terms, nodes are what make the blockchain function, and they're the backbone of the network. If you want to think about them as servers, that wouldn't be a bad analogy. The biggest ones I want to talk about are the full nodes. Those are the ones that are actually doing the validation of blocks and maintaining consensus across the full network. Consensus meaning making the network agree with itself. We'll talk a little bit more of that later. And the main difference between the archival and prune is that one hosts the entire blockchain. A prune network is only kind of the newer pieces of the blockchain to save on hard disk space. If anyone is particularly interested in any of these nodes, I can give you a quick description, but it's more just to illustrate that there are a bunch of types of nodes out there. Anyone got one that catches their eye at all, or?
I actually have a question. Just back, don't go back a page, but
Sure.
you're talking about distributed blockchain specifically. So when you say blockchain, like that Ledger example and Amazon, that's not distributed. So therefore, it's not distributed blockchain. But that was still an example of blockchain, or
so that's an example of Ledger. Ledger is a style of database or a style of record keeping. It would actually be instead of saying blockchain, or how do I put this? Instead of saying blockchain uses Ledger, it would probably be more apt in saying blockchain is a style of. Actually, I have a note on this. What's the best way to? No. Oh yeah,
It's almost like
it's more actually
sorry.
like blockchain is like the newest form of ledger, I guess would be a better way to say that. So because you can have ledger without blockchain.
Also, think of like a Git repository is like a ledger.
Yeah, that's
Yes.
a ledger.
It's
Well, it's also
it's changing commits, chaining commits, and validating through the
Correct.
hashing that history is not changeable.
Correct. So I guess the idea was more to point out that you can have ledger without blockchain, but ledger is a key piece of blockchain.
thank you.
Yeah. Let's see here. So is that one? All right. So now we've got nodes, we've got ledger. Let's talk about networks. So there's a couple types, like there's different ideas behind networks. You got your centralized networks, which behave There's like a single node that is a single point of failure. This would be like hosting a server, in your basement that handles all transactions coming through it. It's controlled by a single person or entity, and failure takes down the entire system. We've all had these issues probably, in the past where you're working with a client and their server goes down and their whole application crashes, and you're like, well, this is why we want you to move to AWS or something like that. Um, then you have your distributed, which this is a lot of the time what we work with these days when you have instances of your application running on different um, servers around the world. In the case of blockchain, you actually have a copy of your ledger spread to multiple nodes and locations. And it's again, in a distributed situation, you typically have it controlled by a single entity or person. They can turn it off if they want to. They can change it if they want to. They control that network. Um, there is no single point of failure. Like if a single node goes down, the whole network can keep going. Um, but then the decentralized idea, it is a type of distributed network, but in this case, decisions are made across various nodes, and each node decides its own behavior as part of that system. So, and each node or each grouping of nodes can be controlled by different individuals, and you basically maintain the network through agreement between those nodes. So I guess the idea here being there's no single person running it, and you can have transactions being processed by different nodes, but then they all kind of come to an agreement or a consensus, and then go, okay, that's actually what's happening. Um, there's a lot of pros and cons to this. I really don't want to get into necessarily political or other things like that, but um, the power behind this is that no single group or person can tell the network what to do. And in some cases, that is a thing that you want to happen. Um, like you can't just have AW or Amazon just decide to turn you off, kind of thing. Um, go ahead.
Oh,
You okay?
can we? It's the confirmation that a entry in the chain is valid is what is being confirmed or denied. Is
Correct.
that correct? Okay, so
Uh, it's well,
and
yes and no. The transaction is being processed and sent and validated by the network. That kind of comes into the hashing later. Um, so it's the transaction that's being verified, not that you have access to the network, if that makes sense.
correct.
Yeah.
That is what I'm saying. So uh, what I'm trying to say is that when you are distributed versus decentralized, there's still a group or some sort of rule that says this is acceptable to the domain or to the network, or this is not acceptable, or this was not a valid thing.
Yes.
Is that true? Yeah.
Yeah.
And so the distributed, there would be some sort of like if 90% of the nodes say we're good,
Yeah.
or right,
Yep.
versus decentralized is saying they'll have a similar rule, but it might be 100%. Okay,
51% usually, actually, but
51%.
yeah,
Okay,
you'll
whatever.
yeah, no, you're good. Yeah, so there is that rule, and
And
there's and the network can keep going even if and when we'll talk a little bit about consensus algorithm mechanisms later, but when the consensus reaches consensus, the network goes, cool, we're all good. Um, yeah. You have anything
thank you.
else on that? Yeah. Um, any other kind of questions on, I guess, nodes or network kind of ideas? And that, I guess the idea here too is that a blockchain can be distributed and controlled by a single entity, and like actually in early stages, that's a good thing. You don't want to have your network just being taken over by somebody else until it's kind of grown to a certain size. Um, but for the most part, a lot of the big ones you're hearing about, Ethereum, um, Cardano, Dogecoin, Bitcoin. That's the one I was trying to think of this whole time. Those are all decentralized.
So
Is
you
our perspective on financial markets or is our perspective on blockchain as a non-financial market application?
In this sense, it is a non-financial technology, but
Okay.
there's a whole thing we could talk about with I'm trying to think of financial, like decentralized finance and uh, what do they call it? The cryptonomics and how these things run and how money is kind of handled by the network in different things and how money is made. And but that would be a future lunch and learn if we want to talk about that.
Well, I don't. I just wanted to understand the perspective because that would really change what distributed versus decentralized is. And you alluded to that
Hmm.
when you're talking about the politics of it.
Yeah, and for today, it's that's a big rabbit hole we could go down. So for time's sake, I think it'd be better to handle that in the future. Or if you want to get beer, we can just chat it out too. So
No, I wanted your perspective. So you're saying this is in a non-financial application.
correct.
Or okay,
Yeah.
thank you.
Yeah, no worries. Any other ones right now? Cool. Let's talk about anonymity. So a lot of the times in the news, you're going to see headlines like people are hiding their money in Bitcoin and they're they're funding all these things that they shouldn't be funding and whatnot. And while that's true and not true in a sense, so Bitcoin is actually pseudo-anonymous, and most cryptocurrency networks, or sorry, most blockchain networks you're talking about are pseudo-anonymous, where so in a truly anonymous network, every user is masked, every transaction is masked. They're typically called like privacy coins or privacy networks. There's literally no way to kind of easily look at the network and see what's going on. Things just kind of happen behind the scenes. But in a pseudo anonymous network, it's actually the opposite. Every single transaction is public. Every wallet, or which is kind of how people interact with the network for the most part, is public. You can actually, if you know the address of somebody's wallet, you can look at it and see, oh, they have one Bitcoin and two Ethereum and whatever. You can look into those things and just see what's there. Could be NFTs, could be whatever, and you can see every single transaction that wallet has ever made on the network. What is masked is who owns that wallet. So if as long as someone doesn't go, hey, that's my wallet, there's no way to. I shouldn't say there's no way. It's very difficult to prove that that wallet belongs to an individual. So I wouldn't know that, or you wouldn't know that I have bought an NFT from OpenSea, or that I have sent money to Ukraine, or that I have, bought Bitcoin off of some network. But you would know that my wallet has. So that's where the distinction lies. And actually, a lot of the time, that's where people are getting caught, is because if they hack a system or are trying to launder money or things like that, every single transaction is recorded. All they have to do, all the people that are trying to track this down need to do is connect that wallet to a person, which typically comes when they try to use that money, like buy a Walmart gift card or things like that. Um, so that's kind of an important concept of how privacy works in these scenarios. It's that even though everything may be public on the chain itself, um, you can still keep personally identifying information secret. Um, and actually, if we ever want to talk about this, a future topic, um, there's ways you can have completely trustless interaction and completely private interaction. Like, no two people need to know who they are; they just have to know that each other has knowledge. That's going to open up a rabbit hole. Forget I said that. Um, idea here is that most networks are pseudo anonymous, and every transaction you do is public. Um, so how that works kind of with your wallets are used to keep your private keys safe, and that's how you can transact on the network itself. It's you essentially sign it with your private. I shouldn't say sign it with your private key. You sign it in such a way that the network knows you are who you are, but your private key is kept completely private. Your public key is a address. It's anyone can see it. They you can, like I said, go on the network. You can open one up. You can see what's in it. You can see where it's transacted. And anyone can actually transact into a wallet as long as they know your public key. If you've ever heard the term airdrop, that's what's happening is somebody said, hey, I'm just going to give this to this wallet, and it just appears in that wallet. In order to transact out of that, that's when you need to know the private key. So somebody can't just go and say, hey, I'm taking that. That's not, well, again, with a caveat, you could have phishing with a smart contract that would enable something like that. But for the most part, they need to know your private key, and you have to approve those things. Or in order, yeah, they don't have to. The transaction has to be verified with your private key, I guess would be the best way of saying that. On top of that, you don't just have to have one wallet, so you can have many wallets. And the wallet ownership is actually controlled by the private keys, so never share that information with anyone unless you want to actually give them access to your connection to the network. There's no undo button. Once a transaction happens, it's on the ledger and it can't be undone. And part of the power of these blockchains is in the fact that you can transact without, or you can have transactions and chunks of code or different things happening without third-party intervention. But at that same point, that third party tends to be your safety net. Like you can't, I'm trying to avoid the financial thing, but it's such an easy thing to use as an example. If somebody steals your credit card and uses it, there's no bank in this case that can undo those transactions. Once that coinage or that NFT or whatever that is leaves your wallet, it's gone. It's been verified across the network. And then, so that's more of a warning for anyone that might be interested in looking at this kind of thing. Back to the wallet ownership being the private keys, you can actually share a wallet with other people. You can have, there's actually things called multi-sig wallets too now, where you can have like an organizational wallet that like multiple people can have signing rights to it, or you can have a wallet that requires multiple approvals for each transaction. So you can actually, that's where you start getting to some of these decentralized organizations or things like that. There's a lot of really cool things you can do with it. Really, I just want to point out that your wallet is essentially your touch point with the chain as a whole. And that's how you pay for things. That's where things are sent from and sent to in the case of digital assets or things like that. And you can give over ownership of it to somebody, or you can share ownership with somebody potentially in different ways. One more important concept is with this wallet and public-private key idea, especially more just to get rid of some of the FUD about people hacking the network and things like that. These networks are, once they're large enough, are hard to hack or nigh impossible. But what is being hacked is essentially people's wallets, and how that happens is there's this idea of hot storage and cold storage, and then there is custodial and non-custodial. So a cold storage wallet, or sorry, let's start with hot storage. A hot storage wallet is connected to the internet. You're going to access it with a normal username and password, and these are susceptible to every type of phishing attack we always talk about. Someone can get your information, or they can hack into a database of those usernames and passwords if somebody doesn't mask things properly, get all that stuff, and then now they can just access your wallet, have a bunch of transactions happen before you even know it. A cold storage wallet is actually one that is not connected to the internet. You'll see a lot of them actually. It's like this. This is a cold storage wallet. It's just a USB stick, has some programming on it. One of the really, really cool things about them is that your private keys never leave that device. when you're signing anything. So the transaction actually happens on the device that's signed, and then it's sent back. Um, that's or you can also have it in a larger sense, um, a separate hard drive on a server somewhere that's not connected to the internet in any way. That could also be considered cold storage. Um, and then you have a custodial wallet, which is a wallet that is run by a company. So, like say Coinbase, they're one of the bigger names you might have heard. You can have a wallet with them, but because it's custodial, they can just tell you you can't use that wallet anymore. They control it. It might be a bad business move on their side or on their point, but they can do that. And then you have non-custodial, which is like what I just showed you. I own that. I control it. Unless somebody comes and takes that from me and knows all my passwords and private key or my and things like that, they can't access it. Um, so, and I guess the next couple slides just to illustrate, you can have a hot wallet or a hot storage wallet that is non-custodial or that is custodial. You can have a hot storage wallet that is non-custodial. An example of this might be what's it called? It's like Smart Wallet or something like that. It's a phone application, but you control that wallet. You can have cold storage, custodial or non-custodial wallets, like what I just showed you, or you could have cold storage custodial wallets, which some like larger companies will keep a majority of their assets, like only 10% of their assets live in a way that can be hacked. Most of them will live in hard drives that are not connected to any network. So if for some reason they get hacked, the hackers only have access to like 10% of their assets. Um, okay.
Hey Josh, can I ask a quick question?
Yeah.
Just to be clear about the private key in the wallet.
Yes.
As I understand it, my identity can be compromised through phishing, through hacking, whatever be the case, but there's no way to get anything out of a wallet without a private key, right?
Yes. But the issue lies in if your wallet is protected by a username and password living out on the internet, like like a
Sure.
hot wallet. So they can get your username and password, which would then give
Totally get
them
it. Yeah.
access to, yeah, to your Coinbase account, and then they can use
If,
that
if
to.
they're on the network and don't have any access to my username and password or some way
Correct.
I'm able to abstract that enough, without a private key, you can't get anything out.
Right, and actually that's a really good point to make. So this cold wallet I'm showing you, like it's not connected to anything, right? Like, but this isn't like this doesn't actually contain the data to like what's in my wallet. This is just my key. Um, my wallet lives out on the network, so anyone can look at it, they can see what's in it, but they can't extract anything from it. You need this to extract from it. Um, and that's so I get to your point. That's a good thing to kind of differentiate is, um, yeah, unless say fish your password somehow in a hot storage situation. But yeah, no one can just get your private key.
Yeah.
So the real advantage here is someone hacks a super admin account, they have access to nobody's wallets.
Exactly. And in the case of that, in a good case of this too would be in like not financial, identity sectors and stuff like that. Like there's, we'll talk a little bit more about it later, but they're looking at storing school information and things like that on blockchain over in Africa. So for reasons, if somebody gets like an admin password of a teacher, they actually don't get access to any of the student information because the students control their own information. Um, and that's hidden in their own like wallets. Um, yeah. Any other questions on kind of how these work?
Are the wallets tied to a specific network, or can they be assigned to multiple networks?
That is a good question. So most wallets are single network. So you'll have like the device I showed you actually has multiple wallets on it, one for Bitcoin, one for Ethereum, things like that. But there are cross-chain solutions kind of being developed, like um, Polkadot is an example of that. Their idea is to allow transition between networks and like communication across networks. In which case, you would have a wallet that kind of handles that sort of idea. Um,
So if you wanted to transfer, say, Bitcoin to Dogecoin or something like that, you would
mhm.
need to have two separate wallets. Or, I mean,
Yes. Yeah.
I hate to use financial as an
No,
example,
you're
but
no, you're good. And it's hard right now because this is a very early stage technology. Like calling it bleeding edge is probably still giving it a little bit too much credit. Um, and we'll talk about that a little more and layering a little. Yeah. Um, but in the case, you can have multiple coins living on the same network. Like I believe Dogecoin is an Ethereum coin. I may be wrong there. Don't quote me. But you could transfer from Ethereum to Doge in the same wallet, because, or maybe I'm thinking of Shiba. It doesn't matter. You could transfer from one, as long as it lives on the same network, you can use the same wallet. But in the case of going from like Bitcoin to Doge, you would have to have two separate wallets. And typically you would be using a layer three kind of solution, which is an application touching multiple networks in order to make that transaction happen. Um, which we'll get, that's actually kind of a cool concept we'll get to in a bit. All right, I got 20 minutes. Unless is anyone super diving for a question? Otherwise, I'm going to hit consensus networks quick. Or consensus mechanisms, not networks. Cool. So now that we've talked about kind of how you interact with the network a little bit, what a node is, what these things are, let's talk a little bit about consensus and how these networks find essentially how it agrees with itself. Because you have all these things, and people are not necessarily running the exact same code base on their network, but they're following the same set of rules. Um, so in the idea of Bitcoin, which is a proof of work network, you may have heard that. There's also like proof of stake, which we'll talk about, or there's many. Um, so in Bitcoin, there's this equation that all the nodes on the network, all the individual servers are like racing to figure out. It's they don't you have a given input, which is all of the data, and you have an expected result, but they don't know how to get from A to B. So they're racing to figure out what that equation is. The first one to get it basically goes, yes, I got it. I broadcast it to the network. They get the new minted Bitcoin and they get a piece of the transaction fees. That's kind of how the network sustains itself and how people pay for power. Um, and it's really, really easy to validate because it's hard to figure out what a equation is based on an input and a result, but it's really, really easy to validate that those things work once you have once you have the equation. Um, and 2x equals 6. If I have a bunch of stuff and I'm expecting 3, or I have x and I have 3, it's like, okay, well, how does this work? And then so okay, 2x, and then you can validate it easily. That was a very bad example because it's a simple equation. Um, so after it's solved and validated, that's when you add it to the ledger. And one of the neat things about these proof of work mechanisms is that you'd think that if you just throw more nodes at the network, it's just the more hash power at the network, you're just going to solve it faster, right? You got more people running equations, it'll just happen faster. Well, there's an algorithm that goes into this where depending on the hash rate or the amount of computing power on the network at any one time, they'll adjust how difficult the equation is to solve so that, it's still going to take roughly 10 minutes if you have, a bunch of nodes or even more nodes. It's still going to take roughly 10 minutes to solve a block and mint new Bitcoin and process the transaction. So in large terms, that's how like a proof of work network runs. They're just literally slamming computing power at it, and that's what kind of secures the network a little bit, because you have to have these pieces and these parts to kind of interact and validate the network. Proof of stake is very, very different. In this case, you still have nodes that are on the network, but instead of them competing to solve an equation and then verify and hash the node and add it to the chain, all that stuff, you actually have users who own a piece of the network in coin. So In this case, we'll talk about Cardano. You'll have these different nodes, and each of those nodes has a weight of money or Cardano pegged to them, basically saying this node is a good node. You can believe this node. And then there's basically a random choosing that goes on where it weights how much each node has kind of backing it, and then assigns the right to validate a node to a certain, or sorry, the right to validate a block to a node. But to keep things not necessarily fair, but from getting really, really centralized and like all the money going to certain nodes and limiting your network, there's kind of a sweet spot. If too much money goes towards a single node or group of nodes, they de-incentivize that by reducing your chances of being able to mint a new block. If there's too little, again, the odds of you getting one are really, really low. So there's the sweet spot where you want a lot of people to believe in you, but not too many, or you want them to be like, hey, go believe in some other nodes, to spread that load out or to spread that kind of idea out. I mean, there's a bunch of other types we could talk. I mean, again, I could do an entire talk about all of these, but it's proof of history, proof of authority, delegated proof of stake. They all kind of work differently. But the idea is that through some mechanism, the network is going, hey, validate this, and then the rest of the nodes will look at it and go, hey, okay, that makes sense. Let's agree. Talking about the hacking before, why these things are hard to hack, you'll hear the 51% attack a lot of time. If a large enough piece of the network is taken over by, say, a single, like I make enough Bitcoin nodes by myself to take over 51% of the network. I now have full control of that network. I can say what happens, what's valid. I can release new code to it. I can do all these things you can do. And this is an example. Each network has their own consensus percentage, but they typically call it a 51% attack, just as you took over the majority of the network. So setting aside a lot of factors, just to talk about it in general, why this is hard is because once a network grows to a certain point, like Bitcoin, it's almost impossible financially to build enough computers to take over that. Like, there's not enough electricity to take over the network, or and as the networks grow, they get more and more secure. So in the case of building a new network, a lot of the time you'll stay centralized and have all control with the person building it. And then once they grow to a certain level, then they sort of release control to the greater ecosystem. So whenever you hear something like, oh, the network was hacked, that's probably more dealing with something like a Coinbase hack, not a Bitcoin hack. Yeah. Any questions there? The next thing we're talking about otherwise is going to be the root hash, which is how a lot of this is really easy to maintain across the network. Cool. All right, root hash. This is really cool. I'm going to kind of flip through these slides kind of quick because it's more demonstrative. So the root hash allows for easy validations across nodes. So it's not like each chain or each node has to validate that another node has the entire blockchain and that every piece of it is correct. You can do that because this is also called a Merkle root for those of you who like cryptography and different things. So if you think of each block as a set of transactional data, when you run it through a hashing algorithm, like a SHA-256 or something like that, there's different ones, you end up with a unique hash based on the data inside of that block. If any piece of data is different than any other, it will be a completely different hash. It's unique. So then you can take those hashes for those blocks and you can hash them together. And then you can kind of keep doing that until you end up with your root hash. So depending on how the chain works, it's not like they're hashing this entire thing every time they're validating a node. You can actually take your root hash and then hash the next block or group of blocks onto that, creating a unique hash for the entire chain. So that way a node can look at another node and they compare that one number or that one string. And then if those strings match, they go, cool, we agree. If they don't match, they go, uh-oh. And then if you could do that across the entire network, you can say, okay, most of us think it's this one number, so that's what's the truth. You're wrong over there. Um, and why this is really, really important is that even if a single transaction changes, if somebody went back into their history on their local node, said, I get 1,000,000 Bitcoin, um, it's going to change your root hash. The rest of the network's going to look at you and go, that's wrong. We're not going to believe you, and then just move on. Um, so it's actually a really, really cool way of, once the network gets big enough, that's where you get the immutable power, because you can't change something in the past if most people don't have that change. And why, once you take the majority of the network, that's where that danger lies, if you're too small, is because somebody can just make something happen in the past, and then it becomes the agreed upon present. Um, so really important concept for kind of how these networks agree with each other and maintain that immutability and prevent hacking. Questions there?
No, but I would like to just pipe in.
Sure.
So it's that the cost is determining the equation. It's the hash that's the output of that you're checking.
Yep.
And so it's easier to check validity than it is to create validity. And that's the whole point of this
Correct.
unit of work, or whatever you call it, the proof of work.
Mm-hmm.
That's the whole point of that, so that you can't spoof a valid ledger entry, because it would take too much work to actually do that, and it
Correct.
can immediately get invalidated. So
Yep.
that concept is what keeps this ledger
Mm-hmm.
pristine, so to speak, or accurate. Thank you.
Yeah, no worries. And as an addendum to that, I'm not going to dive into this piece of it, but if you've ever heard the term of soft forking or hard forking, that's essentially the network coming to a consensus with itself. So if there's a disagreement among nodes, that's a soft fork, and then once they come to agreement, that fork goes away and you kind of merge back together. So that, if you've ever heard those terms, that's in broad strokes what's going on. Is they're figuring out who was right. Okay, so I talked about layering before. This is actually really important into the architecture of things. All right, I got 7 minutes. I'm going to keep plugging. I might go like 5 minutes over. I hope people are okay with that. So you have, think of, on the right hand side, you've got this structure of a blockchain architecture. Think of this as kind of like your tech stack, for better or worse. I'm not going to dive too deep into that. I'm more interested in the layering. So like layer one's your foundation layer. That's it's in charge of your consensus, your programming languages, block time, dispute resolution, all these rules, parameters that provide basic functionality, like we've been talking. It's also sometimes called the implementation layer, if you've heard that term. That would be your Bitcoin, your Ethereum, your Cardano, things like that. Excuse me. A layer two, that's an overlapping network. That it provides additional functionality and typically scalability to the underlying network. So if you've ever heard of Bitcoin's Lightning Network, what that actually is it's a side network doing its own thing that handles a bunch of transactions and processes, and then will touch base with the main network, updating it every once in a while, in broad strokes. So smart contracts dealing with in the layer one, the primary blockchain, typically only deal with like deposits and withdrawals. So it's like so and so gave money to so and so removed, whatever, that kind of idea. At the layer two, that's where you're starting to get into more interesting kind of things. Like you could have a cell phone contract going on, or you could have the trade of goods or services and things like that going on. Layer one is your root network. Layer two, things that add functionality and scalability, so that everything is not hammering the base consensus network. And then you have layer three, and this is more typically referred to as like applications. It's your application layer. It's it's a user interface with how a user is going to interact with that network. It's what really gives blockchains their real world applicability. If you've heard of like PancakeSwap, Axie Infinity, OpenSea, or the LIMS Lite PCP, That's actually a layer 3 DApp that we are working on at Yahara that interfaces with blockchain. Um, yeah, so that's kind of how those things work. So I did mention smart contracts. Again, we could dive super deep into this, and it could even be in its own lunch and learn if we want to. But kind of the core we want to talk about here is that it is essentially an executable program that's run on the blockchain. It can be a digital agreement, it can be a guarantee, it can be pretty much it's 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 a contract. It's if something happens, then this other thing happens, kind of thing. Once the requirements are met, it actually executes itself automatically. Um, and the details of those transactions, they sit on the blockchain forever, or I guess until the blockchain disappears. But the idea is that again, that record is there forever, and anyone can see it. Their main value really lies in reinforcing security and transparency and trust between people or signatories, and to avoid misunderstandings, falsifications, things like that. But it also dispenses with like a third-party intermediary that can slow things down. Um, so I guess a good idea, a good example of how we could do this in simple terms is you have a homeowner that wants to sell their home, and you have a person that wants to buy the home. If the house is digitized and added as a token on the blockchain, you now have a representation of that digitally. This acts as your what do they call it? Your not your lease, your homeownership agreement. I don't remember what those are called right now. Um,
Your
and
deed.
thank you,
Deed.
your deed. So yeah, that acts as your deed, and then the seller has money, typically digital currency, whatever the network is using. Um, you have a contract as formed to say, I'm selling this house for X amount and I'm buying this house. And then once that happens, the smart contract will retrieve and distribute the assets, giving the money to one and the deed to the other person. You don't have to worry about any, it's like automatically clearing and settling. You don't have to wait for banks. You don't have to, all these other things. And the other thing is if the house has been digitized onto a chain, you can actually get its entire history. You can instantly know if there's any liens on it. You can instantly know if there's any like issues with the home that have been brought up and recorded onto that blockchain. So all these things in the housing industry that we have, what, 3, 4, 5 different full industries, can all kind of be automated. Whether you think that's for better or for worse, that's for you to decide, but it is a technical possibility. Which is super powerful and why smart contracts really have a lot of power. You can also, one other example which might be a little easier and more, we talked about before transitioning from like Dogecoin and Bitcoin. There are services like PancakeSwap, which act as traders of those coins. So they'll have someone says, I want to trade Bitcoin for Dogecoin, and they go to PancakeSwap, and PancakeSwap goes, okay, those people are selling it, those people are buying it, or they want to trade between those two currencies. A smart contract is formed saying 1 Bitcoin for 23 Dogecoin. That's absurd, but whatever. Everyone goes cool, and the smart contract goes but up, and now the coins are living in the opposite person's wallets. So you can just have that. No third party got in there and was like, hey, okay, I approve this transaction. There was none of that going on. All right. So I'm going to caveat this one. This is our LIMS Lite PCP. I'm not on this project personally. I talked to Jules, Zach, and a little bit Garrett to get this info. So I might, and it's still early stages, so none of this is set in stone, but it's kind of a cool thing that we are doing in kind of a high level view of that. So we have something called the Metadata Manager in LIMS, which has all of organizational's research data or public health data in it. And right now there's no really there's no good way to share that. So the goal behind this project is to foster more of an openness in data sharing for like these public health lab data, and get information where it needs to be so people can actually use it. Um, it's built on Cosmos using the Tendermint SDK for those interested, um, and it's in conjunction with JMC, who works with the CDC. Um, the As a high level view, like an organizational's data is going to be in Yahara's metadata manager. And if another organization wants access to that, they can create a contract, not a smart contract, different things, with the first organization kind of requesting a category of data. Like, hey, I'd like all your sequencing data or COVID sequencing data, or I'd like all your NCBI data. Um, the contract would then essentially say what I want, like that NCBI data, and then where it's going to be stored. So it'll have, like in the case right now of how it works, it'll have a S3 buckets access keys. So that smart contract would then kind of execute pulling the data from the metadata manager in the form of like a report or some form of data, and then deposit it in the targeted S3 instance where organization 2 now has access to it. So you can kind of think of the contract a little bit like the query. That's not 100% true, but it's like, hey, give me X data in this form and present it to me here. And then why this is kind of cool and why you use blockchain, because I'm sure some of you are thinking, well, we could just handle that through a sharing through a metadata manager. And you're like, well, yeah, technically you could, but currently Yahara is running the only validator node, but as it matures, we'd actually shove that responsibility out on the member organizations. So each organization is going to have a node, and that's going to respond to messages on the network that's going to be, hey, can I get a contract with you to share this data? I'd like it here. And then they can also monitor their network. So if they see, so like say I'm another organization and I'm seeing organization 1 is sharing data with org 2 about COVID sequencing, and I'm like, that's really pertinent to my work. I can actually then basically sign on to that and request that same data sharing, without having to go through any of these hoops or jumps or skips. Like you can, through the network itself, can maintain, because org 1 is like, I'm willing to share this information. I'm like, or org 2 is like, I want that information, and I look at it and I'm like, I also want that information. Hey, org 1, give me that information. So you really open up the ability to share this data. If there's specific questions on this, I honestly don't know if I could answer them, but you can try asking if anyone has any. Cool. All right. Oh shoot, I'm already over time, so I'm going to close out really quickly. Just some other ideas and use cases. You got decentralized finance, which we've talked about a little bit, sending money overseas, Ukraine donations without any intermediaries that happen fast and can be converted into local currency without a lot of overhead. You have the decentralized identification, kind of what I talked about in Africa. People can maintain their identities and their like I'm a doctor, I have proof I'm a doctor, even if I have to leave my country for some reason. Housing market, we talked a little bit about that. Another cool one is like supply chain. If there's like an outbreak of salmonella, you can instantly know if everything's recorded through that, recorded on a chain. You can know where those crops were, what trucks they were on, what manufacturing facilities, where they were caught, what boat. Say like the fish was caught in this boat, put on this truck, put to this manufacturer, then sent to the store. You can like track all the way up almost basically instantaneously, and then alert other people that might need to be made aware. So these are like some interesting concepts of how it can be used. And closing up, if you ever want to talk more of this stuff, here's some other future topics potentially, or if you just want to like hang out and chat and talk about this kind of thing. I love blockchain. I love the potential of it. I think that it's really cool that Yahara is starting to dabble in it and get our toes wet. But yeah, any of these topics, I think NFTs might be a popular one, just because that's in the news a lot. And no, they're not just silly pictures. There's actually use cases for these things. But yeah, I guess since we are late on time, I'll wrap up there. But if there's final questions, please let me know. Or if you ever want me to do more on this, deeper dive on anything, I'm more than willing. So.
Thank you. This was a great presentation.
Thank you.
Thank you.
Thank you.
Yeah. Stop my recording.